Hi, welcome to NedDev. Today we're going to be building a directory buster. I've been playing a lot of Hack the Box recently, and when you find a machine which has a web server running on it, you use a tool called a directory buster to understand more about that web server and what endpoints are available without having to test every possible combination. So what we'll be doing in this project is building a simpler version of a tool like GoBuster or Derb. So I've got my project open here. I've called it perl-buster, and I'm going to be using GitHub to store the code. First thing I want to do is create a file where I can create some requirements for the project. So let's call that to do. Right, so I've created a list of requirements for the program, and I'm going to run through them quickly. So they are the sort of basic requirements for a program like this to work. The first two things are the ability to pass in a file of new line separated words, which are like the most common endpoints you find on a website. And that's how you can enumerate the website and sort of build a picture of the directories. So the next is to pass in a base URL. So for instance, like google.com and then / and it'll go through each of the words, testing if each of them, it can reach each of them. So I want this to be just a command line program where I don't have to go in and write code. I just want to be able to pass in arguments, so -u for URL, -w for words. The next one is to test the response code, because I will get a response code from each of them. So if I get a 404 or a 400 type response code, I just want to throw it away. And if I get a 200 or maybe a 300, then I might keep them. I will keep them. The next is option for a file output. So I could just, append the output of this into a file or tee it off into a file, but I want there to be like a command line option to be able to do that. The next is maybe some information about the execution time, and lastly the ability to slow down the request, just so if there's like an IP blocker that's stopping machines from what we're doing, then we might want to slow it down and just do like one request a second or something really slow. Cool, so we've got all of our requirements. We're going to move on and create a file called perl-buster, and this will be a script, Perl script. Also, I'll start putting in all of our boilerplate, so that'll be user bin perl and use strict and use warnings. Okie dokie. Now let's give this a name so people know what they're looking at when they come inside of it, and we'll do something like this. Copy that down. And we'll copy this down. Some kind of obnoxious thing. Cool. Okie dokie. Now people definitely know what they're looking at when they're inside this file. Now the first thing we want to do, or the first thing I want to do when building this, if I go back to the to-do list, is not these. The first thing I want to do is start setting up command line arguments, because this is something we're going to add to as features roll in. So the module we're going to use for this is use and get opt and capital STD. And now this is a built-in, so you won't have to install anything for this. First of all, as the first thing that happens when this program runs, I just want to print out the title. So when you execute a command, then it just prints out what it is, and you know what the program's now about to do. So to do this, because this is going to be a multi-line thing, I'm going to use this, call it head, and in here I'm going to do a similar thing that I've done up there. And head. There we go. So now we can test this. So I can go perl-buster, and we just get a printout of the program itself. Let's create a comment called options to know what's going to come next, and we need a hash to store our options. There we go. Now the getOps function takes as its first argument the list of arguments you are going to use. So if you were to just type a letter, then it would expect only that letter and store it as an option in your options hash. If you do letter and then colon, then it expects something to come after that argument. So we'll start off with just H, and this will be our help option, and that's something we're going to keep on adding to as we go through. And now we pass in a reference to our options list, as well as creating an area for our options. We're going to create an area above it for our functions. Now in here I'm going to write gethelp, and this is going to be our first function, so sub gethelp, and in here is going to be everything that gets printed out when we request help from the command line. So to do this, we'll do print to our standard output, and we'll call this help. It'll be a multi-line print. So here we'll say we will run gethelp. Oops. If our options H exist, so if defined. Now this will run, so if I put help me in here, this function will run if we use the -h command. So nothing prints out, and now if I go -h, we get help me. And this is useful because as we start to add in features, we can just list them here, and then this becomes a bit of a help bar for us as we write it. In our help, I want to usage. So tab in, and we'll say perlbuster, and then any args. I want an example to go along with that, so perl-buster, and then -u, so here we would want URL, base URL, and maybe here we'd have the word list, and that would be a basic example of how to use the program. So lastly, we want to actually list the flags. First of all, we've got -h, and this is our help me what this program does. Cool. Okay, so that's a very basic help, but that gives us a skeleton to work from. So every time we add a new flag, we just put it in here, and then and then write what it does. But we know that we want two other ones. So we know that we want to be able to pass a base URL, and we want to pass in the wordlist file. More accurately, that's the path to. If we come here and say perlbuster -h, we'll get a nice printout of our help. So we've got usage, an example, and the list of flags. Okay, so I'd say that's pretty good for setting command line arguments. We haven't quite finished it, but I'd say we are done for now. And we'll just add them as we go. So the next thing to do is, or to pass in URL. We'll go with this because this one's slightly more complex. So we can start to actually ping the website. To do this, we're going to use the module LWP. So come up to our modules and we go LWP and space 5.64. Now this is something you will have to install, so that'd be cpan install LWP, and then whichever version of it you want to use, but I think that should just work. So as you can see, I've just installed it and it says LWP is up to date. Cool. Okie dokie. So the next thing to do is use it. So to use LWP, we want to set up a browser and then use that browser to get the information, so to send a request. Now to set up a browser, let's make another function, so get browser. Now in here, this will be a super simple thing, and what we'll do is return browser. I won't need to do that. We can just return LWP user agent new, and a bit of safety, we can do that or die, and give us a reason why. Not forgetting our sub keyword. Cool. Okay, so this is our main loop, if you like. And we can say my browser is equal to get browser. Now this should run, but nothing happens. So we want to do something with that browser. And to do something with that browser, we're going to need to pass in a URL and then get the browser to do a GET request. So for now, we'll just hardcode this in and say my URL is equal to www.google.com. And then we want to use the browser and pass in that URL. Okay, and then from that GET request, what we want to do is get the response. Now our response needs to be stored in another scalar. We can say print to our standard output our response. So I've just noticed something here, and I will just run our program. So it's going to get browser, put the URL inside of our browser and send off a GET request, and through that GET request we'll get the response, so that'll be the page. So this is just as if you would go to your Chrome browser or whatever, type in www.google.com, and then it gives you the HTML, CSS and JavaScript and any HTTP headers that come along with that, and then your browser can display the page for you. But this is obviously not going to give us anything graphical, it's just going to give us the basic information as the response that we've put in here, and then we're going to dump that all out. So let's run it. And yeah, so this is what I saw earlier. We're going to get a response code 400, the message being your URL must be absolute. Now to fix this, we need to say the full path, the full absolute path, which is http://. Now let's rerun this again, and we get the page. We get all the JavaScript, CSS, and HTML, and somewhere we should see 200. Okay, there we go. So that's our response code, and 200 is that's a good page. That means the browser will be able to display it properly. Okie dokie. So because of that, we can actually make our requirements a little bit, or add to our requirements. We can say use regex to add absolute path where it doesn't exist. When it doesn't exist. That makes sense to me. I'm not sure that makes sense to everyone, but basically what I mean is if I just as a command line argument put www.google.com, then some regex can look through that, see that there's no HTTP // and just stick that at the beginning and shove that into the browser as an automatic thing. And if it's there, then it doesn't need to do it. So we still want to be able to pass in a URL through the command line. So we want to say perlbuster -u http google.com. We want to be able to pass that in, and currently that just works because it's doing this, but we want to be able to pass in that argument and to be able to use it. So let's go up to our getOps and create a new command line argument. So it's expecting -u with a semicolon, so we want to, it will pass in whatever comes after it. Let's get rid of that. So we've already put that in our flags. -u base URL, that's what we want to do. And we can assign, we want to basically cut that out and assign my URL to be options. Oops. U if defined. So again, using that same syntax as above. If that command line argument is defined, then I've just seen another issue. Right, so if that's defined, then we want our URL to be used. So let's test this out. Oops, let's add a U. Okay, so that's still giving us Google stuff. So what happens if we don't pass in that argument? Okay, so it's giving us a 400 response, but we can already expect that. We don't have to set up the browser and make a request to know that not having a URL and requesting is going to give us a bad response. So what we should do is say, if it's not defined, so or we can just die and say that we need to, so please use the -u flag to pass in a URL. Use -h for help. Right, so let's test that again. So let's say google.com. All right, it runs, gives us Google. Now let's give it nothing. Okay, it dies and says, please use the -u flag to pass in a URL and use -h for help. And it tells us at what line it died. Although I'm not sure it really needs to do that. Okay, that's fine. But I've also realised if we did -h, then we are also going to get this. So we want this to exit once it prints out. So we can say here exits. Now I think that should work. Right, no, that's not the correct syntax. So it's actually just exit, and then we can express an exit code, 0 being the default, so I don't think we need to say 0. And up here I have a mistake, there should be an end of line, semicolon. Let's try and run this. Okay, cool, so it exits as soon as it prints the help statement. And if we get rid of that, then it says, right, please use the -u flag. Great. Where are we at? So we have passed in that, put some protection in there, some information. What else needs to be done? So we've passed in the URL. I'd say that's done. We can come on to these secondary requirements later. So pass in a file of common words. Okay, so we'll move on to that next. For a word list, I found this one online, which contains hundreds and hundreds of common endpoints. So browser, blah blah blah. There'll probably be one for admin pages, admin.php is a common one. And what I did is I just copied this out and put it into a file. Okay, so I copied that, and let's create a name for the file. So common.txt, and also what I'm going to do, because I don't want to include that in my GitHub repository, I'm going to make a .git ignore. Yeah, that should do it. And say common.txt. Now that won't be tracked. Cool. Okay, so that aside, let's go into common. And I've already copied in all the words, so that's 4,614 common words. So that would be plus a space at the start. So that will just request the website as its base URL. And if that comes back as 400, then you've got no hope. So, yes. Cool. So we've got our word list, and now what we want to be able to do is say perlbuster -u http google.com and then -w, and so it'll be let's say a relative path to common, and that's the command I want to be able to use to request and then go through all of those words. So yeah, as it is, passing in that argument does nothing. So right, let's go back to our script, go back to getops and w and a semicolon. Let's do something with our w arguments. So let's pass in, or let's presume we've already made a get word list function, and into that we're going to pass in our options with the w flag. but if it is defined, yeah, options, if that option is defined. If not, we want to do the same thing as above and die with an error message and say, please use the -w flag, flag, and pass in a path to a word list. Use -h for help. Or maybe it would make more sense to just call gethelp. I mean, this is specific to the issue. So what we could do here is just say gethelp, and then if it's not defined, then it just prints out help. So I'm not sure what's better actually. Maybe a specific piece of information. So we'll terminate that and put it in a new line. Please use the -w flag and pass in the path, a path to a word list. Right, so let's actually do something with this. So let's create that subroutine. So we'll come up here to our functions. Yeah, so in the functions we're gonna use our sub keyword, get that open, and say my file name is equal to what we're passing in, which is that -w argument. We'll just print that out for now. So file name, cool. Get rid of this output. Close that out. Oops. And then we just get common. So that is correctly being passed in there. Correctly being passed into that -w argument, and then being printed out in this word list. So, but that's not doing actually what we wanted to do. So what we wanted to do is open up a file handle and call that fh, and the mode we want to open it up in is read. So that's read, that's write, and that's append, I believe, or that might be append, and that might be right. Either way, that's read. And then the path to our file, so that's the file name, or more accurately, that should be called file path. Alright, doesn't really matter. And then we can return to the caller the file handle itself. So does this work? Right, okay, I haven't declared that properly, so hopefully this should work. But it's not. It's opening up the file, but it's returning it, but it's not actually assigning it to anything or doing anything with it. So what we can do is come down to here and say my word list, and what we can do is now make this a little bit neater, I think. So if I come up there, so we'll just put these two in line just to make sure that looks fine. And cool. Right, let's do something with that word list. So we've proved that we can open a browser. We have, actually I can tick that off our to do, so we can pass in our file of common words. We have, we're not testing specific response code, so let's see if we can do that. So I'll go back to here, uncomment these, make sure everything's working, and in our response, instead of the whole response, let's print out a specific part of it. So let's say underscore response code. Cool, and 200. And that is what we're looking for essentially. Okay, so we've got our word list, we've got our response code. So I think test response code, probably call that done. And now what we really need to do is the actual crux of the thing. So we'll open up a new requirement and say, actually, we'll undo this as done. We'll see test the response code of each URL plus word. There we go. That makes it a bit more defined, and that's the actual meat of it. Right. So we can keep that stuff, and what we'll do is we'll open up a while loop and say, where's our word list? So that our word list should be this file handle, and we can start by just printing out each of the words in the word list. So for our standard output, we are going to print out the built-in variable. Cool. Now that should have, printed out. Oh, actually, each of them are on a new line anyway, so we don't need a new line character. And we get 4,000 odd words. That fills up my buffer. Right. Cool. That works. So what we want to do is actually start bringing each of these things in and say we want a response from the URL. Well, let's, because I don't want to make anything too noisy to start with. I think we're going to have to think ahead a little bit and put in just a simple sleep function. It's probably not the smartest way of doing this. And then in that sleep function, we can pass in a command line argument. So what we can do is come up here and say t for time, and then my sleep time could be equal to options t if defined options t. We'll start off with that for now. We'll just print out what sleep time is so we know. Okay, so let's test this out. Let's try and pass in a time, so -t2, and then we can see that it prints out 2. That's fine. Right, this might be actually a good place to set a default. So I don't really like them, but this would be a good place to have a ternary operator, just to keep everything on one line. And to do that, we would say, take this out, say if defined that, then we want to set it to that, or if it's not defined, then we will set it to 1 as a standard. And then we can see, I got something wrong. What have I done wrong? Right, it's an if anyway, so we don't need to use that. Cool, okay, so it sets it to 2 seconds, and then if I don't have it, I should set it to 1. There we go. So our default is just a 1 second. We can amend that later. We can get rid of that because we know it works. And pass down into here and say sleep time. Cool. And now what we should see is each of the words from the word list being printed out with a 1 second delay. Yeah, that's about right. And so let's test it and say -t 0.1 and see if it starts coming out a lot faster. Yeah, there we go. That makes sense. We can keep that at 2 just whilst we're testing. Let's go back to our to-do. Set a response code for each URL plus word. Ability to slow down requests. Okay, we've done that. Cool. Let's start actually requesting each of those things. First of all, let us try and concatenate to, let's go with this. So what we want is the base URL plus / and then the word. So put that in there, /. Let's run that. And we are, apart from that, RC there. Cool, okay. We are getting each of these things. That's fine. So let's actually pipe that into a response. Let's get a response from the server. So response equals that gubbins in there. And let's print out the response code. Now, am I about to make everything explode? No, but I can make that better by putting a space in there. Okay. So what you can see is here I've got a 200 OK response from Google, and then from these first ones, which they look like command line. These are command line files. I'm not getting anything from them, so let us speed this up a bit. Let's see what else comes up. So they're all 404s. Maybe this wasn't the best word list file. There we go, so we're getting some 200s there. So it's a lot slower on the 200s. So yeah, cool, okay. Now what we need to do is try and separate out between the responses that we want to see and the responses we don't want to see. Maybe we can clean this up a little bit. So we don't let us format this in such a way it's easy to read. So what we'll do is say that response code is coming from and this URL. This is what we want to use. And then we can get rid of this and see if this formats it a bit nicer. Cool, okay, that's a bit nicer, and we don't need that new line character. Okie dokie. And right, now we need to separate out what we need. So maybe the best thing to do here is make a function that gets the response code for us, and then we can decide to print out what we want based on that response code. So let's come up to our functions and say sub get response and that will be equal to a URL we're being passed in. And then we want to get the response. That will be equal to this. This is exactly what that is. but we'll pass it in as a formatted URL. And then we want to return the response. Okay, that seems fair. We can come here and just say get response code. We can pass in this as a URL, and that is equal to RC, which is our response code. Okay, so if we get rid of that, so that's now redundant, we'll try and run this and see how many errors we get. Okay, it's global symbol browser requires. Oh, okay, yeah, that's not being passed in. So browser, pass in browser here, I reckon. What else is wrong? Response is not a word. So response. Browser. Are we good? Maybe. Line 82. Alright, yeah, so we actually need to pass that in. So RC, cool. A lot was going wrong there. Alright, cool, so this is still giving us 404s. So what I need to do is on here I can say if RC and then use some regex, so this 2 brackets, and then we want probably just looking for the start of the line and a 2, and that would say and then that would be any 200 response code. So from 200 up to 299. Now you see these 404s are no longer getting printed out. Actually, let's make this a bit faster. Cool. Okay, so there's some other things that are coming up. Let's go to our to-do and let's pick a new one. So info on the execution time. Cool, we can do that. Let's at the start, so just after we've got on our browser, we could say my s time is equal to time, and then my end time be down here, or let's make that more obvious, so start, stop, and then we can print. Oh, I don't even need to say that it's the stop time. We can just say print and so that would be time to execute. That'll be our time. Take away our start time. Let's see if that makes any sense. We'll have to wait for that to run. You can see it picking up all these things. Robots.txt, saves, script, search. And time to execute was 20 seconds. Cool. So we can put that in brackets. So that's 20 seconds. Cool. We can tick that one off the list. Done. And use regex to add absolute path when it doesn't exist. So that means when we pass this in, if we don't pass in HTTP, it could automatically add it on. That would need to be done up here. So we can make a new function for that, I think. So sub get URL absolute or get absolute URL. Okay, so what's going on there? We say URL arg. Right, so what we can do is open up an if statement and say if that URL arg is matching with HTTP // escaping those two, then we can say print yay, else print nay, and see if that runs. Cool. Okay, so we can see that it does. And if we get rid of HTTP, then nay. And the time to execute is 0. So, instead of yay and nay, what we can do is actually do something useful. So if it does have it, then we don't actually want to do anything. So what we can turn that to, if it does not have it, then we'll do something. Say return URL arg. So if it doesn't have it, then we want URL arg. Oops. Come on. URL arg to be equal to HTTP. And concatenated with the URL arg. Now, I think this should work. Alright, so the reason why this isn't working is because this is returning that corrected string, but not doing anything with it, so it's not assigning it to URL. There we go. Alright. Now it's giving us the correct stuff. Cool, that seems fair. And instead of having this whole extra line here, I think what we can do is just... yeah, we can do that. We can check that before. Get rid of this line. Cool. Okay, now we're getting stuff for google.com without HTTP, and then if we write HTTP // and then we still get stuff. Cool, that's something else we can tick off the list. Oops. Done. What else is there? Right, the last thing, file output. So I want another command line argument to say I want to send this all this information to an output. Let's do that. Right. Let's come back to get ops and say O. Oops. Not 0. O. And that can be our output location. Find. No, we want it to be. Yeah, is equal to options. Now, if it's not defined, I don't think we really want to do anything. We just want to let nothing happen, essentially. This assignment won't happen if it's not defined. So then we can test if output lock is defined, then we can send it all to a file. So right, we want to create another function to deal with sending things into a specific file and appending them onto the end of that file. Let's create that function up here. So we'll go sub and write to file. We want our our location is equal to the first argument being passed in, and similar to our very similar, we can just say my file handle, and then we want to append to location. Cool. I feel like there's some more tests we need to do to make sure this location is okay. What we can do in here is write to file or die, and then with whatever error is passed through. Alright, so I think what we should do is get that function to return straight away. So do it all in that one line. And that way, I think this should, if we don't specify a file, then it won't do anything. But if we specify an output file and call that log.txt, yeah, cool. Right, so we've got an output log file. Nothing's being written to it, but it's actually there, which is good. So let's start sending stuff into that file. So what we can do is go print and then say our output location. So that will be as if it's that standard output, and we can say then that we want all of this, I believe. We need to make this a bit more streamlined, but we'll see if that works. So let's delete. I've already deleted it. And let's run this. Erroneously. I have missed off the semicolon. So our log file is opened. There's an error here. So what we want to do is close that file handle at the end. So we can say before that, close and output location. Right, let's have a look in this file, and cool. So we've got all of our 200s and in a nice place. So, but maybe we don't really need the response because we know it's a 200. So what we'll do instead is take out the response code and keep the URL, keep if it's that, and say if it's that, and defined output location. Now, what should happen here if I delete this? If we get rid of this, run it, then we don't get anything happening because this isn't defined. And if we do this, and say it runs the whole way through, then open the file, It's probably because it's not finished handling it yet. Maybe. Maybe it has to open the file every time it wants to append to it. Otherwise it'll have a hold in the file. If the program doesn't end, then then something goes wrong with the way the writing to it works. I'm not sure. Let's try and write this slightly differently. So instead of writing to file location and info, let's print the info. That seems to make a bit more sense, so let's get rid of that from there. And that's what we want to put in there, and we want to put this on the end. Now that's a big change without doing any tests, so hopefully this works. And that's the important bit. We want to close it off each time we write into it. I'll delete that. So what have I done wrong here? I have 81. Alright, I haven't used the new location variable within the scope of this function. Now hopefully we can see this live updating instead. Yeah, that's much better. And then if we just end the program, then we can still access it and it's still there. We can delete it and say get rid of this, test to see what happens. Now what should happen is nothing. There's no location, output location. Sweet, yeah. Now there's a really obvious thing we can do to make this a hell of a lot more efficient, and that is my full URL, call it that, and that can be equal to this. Okay, that still seems to be working. What else can we make better? So they can go together. That prints to the output, and maybe it's worth having a quiet mode. Maybe you just want this to run in the background without actually printing out to the console. So we come up here and we say just Q, and then say my quiet mode is equal to this with the Q, and then we can say output to that and defined. Not defined, because we want it to write to the output, and then if we do a -q, nothing happens. until the end of the program. So that's fine. This basically all works. There's a lot of things that could be done to make this better, but for now that's okay. I've got a file output. Oh, we need to update the get ops. -q node nothing printed to no, not nothing, it's no responses printed to console. What else other arguments we got on there? O is our output file. And I think we are there. So let's do a bit of testing. They don't need to have anything else happen. Yeah, I think we're good. So right, let's do this. So the basic things we need are this. And then we get our outputs. If we get rid of HTTP, we should still get something. If we say quiet mode, we get nothing printed out. But quiet mode only really makes sense if you have a output location. log1.txt, or you might say Google dir, and then we get a Google dir here. That's fine. Let's get rid of quiet mode. We get that printing it again. What else do we have? Yeah, I think that's it. Cool. So that was a cool little project. I'll put that into GitHub and link to it. So if you have any suggestions or anything that I did completely wrong, then please let me know, comment, and I'll see you in the next one.